Today I'll be demonstrating my physics project, which is a 2D physics simulator. So, how it works is that when you open the project, you are shown a sphere that can have velocities and acceleration vectors of varying angles applied onto it. After applying the various vectors, you can then press compile to see what happens to the ball. For example, how far it will travel, how high it will go, and the velocity upon hitting the ground. I'm interested in this project because free body diagrams are my favorite part about physics. Plus, it seems like the most applicable part of physics that can be used in the real world. In addition to all of this, I personally find that being able to see the path of a ball being flung based on certain velocities and vectors to be a nice thing to see. For the free body diagram simulator, I need the equations for projectile motion, which are listed on the screen here in no particular order. These are time airborne, distance traveled, maximum height, and final velocity in terms of x and y. X in this case representing the distance traveled, and y in this case representing the height traveled. To create the 2D physics simulator, I use TurboWarp, which is basically just Scratch, but you can convert projects made on it into HTML files. The simulator can also be used to solve actual physics problems, which I will demonstrate for you now. Okay, so here's the 2D motion simulator. To get started, you have to click this button here to start it. And once you open up the project, you're given a lot of options here. So for example, this one is to customize the height of the ball, or basically how far it starts up. This one is gravity, which pushes it down. And this one is radius, which doesn't really do anything. It just makes the ball look bigger or smaller. You can see the ground kind of moves up and down with it, so this is more of a visual change. If you want like a custom height of gravity, you can click this button here to get a text box, which you can put in a very specific number with you. For example, we can put like a 10.35, and we have a very specific height. You can't do that with a slider because it just gives you like a whole number. Same thing with gravity here. Let's say we want like 9.81, and behold, we have gravity here. Now, if we wanted to add like a vector or something, we could click this button here. And now we have a arrow, which can be used to, put like a vector on the ball. We can change its angle, we can change its force, or basically how much it pushes the ball. We can also change its type. So like we can make it a velocity or an acceleration vector. And we can also put in like as many vectors as we want onto the ball. So like, yeah, you could have like I think up to 99 different vectors on here, but realistically, I'm hoping you're not gonna need that many. So I guess for like a demonstration of how it works, you could have it ball facing in this angle with a default height or starting height of like 12 and the gravity of, let's say, 9.81. Oh yeah, by the way, all of this is in meters per second. So like the gravity is supposed to be like 9.81 meters per second, height is 12 meters, radius is I guess 1 meter. That's what I was kind of hoping for, anyways. Uh, so if we click compile with this stuff, we have a gravity of 9.81, height of 12, and this one velocity vector, we can click compile. And here we can see the end result of all that. For example, we got the initial x velocity and y velocity, the x acceleration and y acceleration, although this is the total. We also got the distance it'll travel and the maximum height it will reach, and some other stuff like how long it'll be in the air for, its initial height, which we already set. We also got the x velocity upon hitting the ground and the y velocity upon hitting the ground. So if we were to click run simulation and click launch, it basically shows a path of what the ball would take. And here we have like how long it's expected to take, how long it would have actually taken in real life, or how long it's simulated is. This is how long it took for the project to actually simulate this entire thing. And this is basically how many of these dots there are. That's what the clone count is. We can also lower the precision, which will make it run a lot faster, but there'll be a lot less dots. So if we were to click it now, yeah, see, it went a lot faster, but there's only like 6 clones here. So yeah, that's basically how to use this thing. Oh, and if you want to ever use like more than 2 vectors for like, let me just add this gravity thing here. Yeah, if you want to like use more than 2 and you want to switch between the two different like vectors, you can use these buttons here to basically choose which one of these arrow things you want to select. You can't select gravity though. That's its own special thing. Although if you want to like simulate it, you could just get one of these arrows here, set to 180 degrees, and then change the type to acceleration. So basically, if you don't want to use gravity for some reason, you can always just use this as a gravity arrow. And if you ever want to like reset this entire thing back to its defaults, you can go back, click reset, and if you go back here, then it's all reset. Okay, so now what I'm going to do is I'm going to show you how to use this simulator to solve actual physics problems. So in this example here, we're given that the height is 8 meters. The angle is 27 degrees below the horizontal. So if you were to add it onto our physics simulator, we need to add like 90 degrees. And it's launched at a velocity of 17 meters per second. And we're supposed to find the speed in meters per second with which the stone strikes the ground. Okay, so to begin, we could first start by setting the height here to 8. Gravity would be 9.81 because that's like how much gravity normally is. And then we were told that there was like a what was it? I think it was like a vector of 27 degrees below the horizontal. But like, okay, so for here, in order to simulate that, we'll have to take like 27 but add 90 to it. So we'll have to set this to like 117 to get that specific angle. And the force, they said it was like 17. So yeah, this would be a good representation of that. Radius, we don't really care about that. Again, this is just a cosmetic thing, so we can set it to whatever we want, and it won't really matter. So if we click compile, we see that the x velocity pointing to the ground is this, and the y velocity is this. Now, the question asks for the total speed in meters per second. So I think we could just use the Pythagorean theorem on these two to get like the end result. Okay, so I opened Desmos and it told me that the total velocity for those two combined would be 21.11. All right, and if we were to look at the actual answer for the problem, it is, yeah, that seems about right. If you want to try this project out for yourself, you can go to the link shown in the giant red circle above, or if you don't feel like typing all that out, you can always just look in the description.